Hello. So if the wave particles oscillate perpendicularly to the direction of wave travel, it's called a transverse wave. If the wave particles oscillate parallel to the direction of wave travel, then it's called a longitudinal wave. If you are watching the video right now, you are experiencing a transverse wave. What do you think I'm talking about? It's the light wave, of course. So what's oscillating in a light wave? Well, two things actually. There's the drawn in blue, there's the oscillating electric field. And perpendicular to it, there's the oscillating magnetic field. And so because of these two oscillations, we have a light wave that is propagating along this direction rightward. So see, the E field and the B field are both perpendicular to the direction of wave travel. That's why light wave is a transverse wave. So what is the oscillating particles? What is the medium? Electric field and magnetic field can exist in a vacuum, you know. So actually light does not require a medium. In fact, light travels at a faster speed in vacuum. It's actually crucial that light can travel in a vacuum. That's how the light from the sun, the stars can arrive on Earth. So we can see the sun, but we cannot hear the sun, you know. When we were talking about sound, I already mentioned that the amplitude of the pressure variation determines the loudness of the sound. And the period of the pressure wave determines whether it's a low-pitched sound or the high-pitched sound. So what about light wave? So the amplitude of the electric field's oscillation determines how bright or how dim the light is. As for the frequency of the wave, that determines the color of the light. So I'm talking about the visible light, yeah? So the visible light, the wavelength varies from as short as 400 nanometer, which is the violet light, the violet end of the visible spectrum, all the way to 750 nanometers, which is the red end of the visible spectrum. So can light have a wavelength shorter than 400 nanometers? Yes, of course. So those are called ultraviolet light. Invisible to the human eye, but it exists. If the wavelength is longer than 750 nanometer, we have what's called the infrared. The visible spectrum occupies a very tiny range of the entire electromagnetic spectrum. So when we use the word light, we may mean the visible spectrum, or we may actually mean the entire electromagnetic spectrum. When the wavelength is as long as a few cm, we have the microwave. Even longer, at a few meters wavelength, we have the radio waves. On the other end, when the wavelength is as short as 10 to the power of negative 10 meters, we have the X-rays. Even shorter wavelength, at maybe about 10 to the power of negative 12, 13 or 14, we have the gamma rays. So are we sure radio waves, microwaves, visible lights, X-rays, gamma rays, they feel quite different, you know? Are we sure that they are really part of the same family? Yes, they do. They all travel at the same speed. 3.00 times 10 to the power of 8 meter per second. Personally, I always feel that there's something special about light. It's the one thing that makes me wonder whether God really exists. Anyway, see you in the next video. Ta-ta!